Okay, so let's discuss merge sort. So merge sort is one of my favorite algorithms and it covers a lot of problems in DSA. So in a lot of problems, we need to sort in optimal time complexity. So merge sort is one of them. Now, it covers a lot of problems like count inversions, merge intervals, okay, merge to sorted array, merge linked list. So it has a lot of applications. Okay, so let's start what is merge sort. So it is nothing but a comparison based sorting algorithm. Comparison based sorting algorithm. Okay, so what we do in merge sort, we compare the elements and then sort. So it is one of the comparison based sorting algorithms. So we have two types of algorithms. One is comparison based and one is non-comparison based. So comparison based algorithms covers merge sort, quick sort, heap sort, insertion sort, bubble sort, selection sort, right? Now non-comparison based includes bucket sort, right? Radix sort. So they are non-comparison based. So merge sort is our comparison based sorting algorithms. Okay. Now what is second point? It is divide and conquer algorithm. It is divide and conquer algorithms. So if you don't know about divide and conquer algorithms, you can read. So the basic idea is we divide our array or we divide our problem in sub problems. Okay. So we divide our bigger problem in smaller sub problems. Now we solve them. Okay. So if after dividing the problem, it is also a bigger problem, then we again divide it. Okay. So we keep on dividing the problem into our subproblems until it becomes very small to solve. Okay, so we will see how it is divide and conquer algorithms. Now after dividing, what we do? We solve them. Okay, and we combine the solution of smaller subproblems. Okay, so after solving small subproblems, we will combine them and then solve our bigger problem. Okay, that's how we should do in life also. We should break our bigger problems in smaller problems and then solve them individually. Okay, so let's see how it works. Let's say we have an array. So this is our array. Okay, and these are our elements. So it starts from, let's say, 0, 1, 2, 3, 4, 5, 6, right? So we have 7 elements from 0 to 6. Okay, let's take an elements 3, 1, 2, 7, 5, 4, 6. Okay, so these are elements. So we can see these are not in sorted order, right? 3, 1, 2, then 7, then 5, then 4, then 6. So what we want to do? We want to sort. We want to sort the array. Okay, so after the sorting, the array should look like 1, 2, 3, 4, 5, 6, 7. Great. So after sorting, array should look like this. Okay. So I want to sort using merge sort. Now let's see how we can sort this. So as I told you, it is a divide and conquer algorithm. What it does, it breaks our problem in sub problem. So right now our problem is bigger problem. Let's break it into smaller problem. Let's break it. So if I break it, it will look something like this. Okay, I want to break it equally. Okay, so if there are even numbers, let's say there are 6 elements, so I can break 3 and 3. Okay, let's say there are 7 elements, then what I can do, I can take 4 and 3 or 3 and 4. Okay, in each of the partition. So we divide it equally. Okay, so we have 7 elements, so let's say 4 elements here and 3 elements here. Okay, so it will be 3, 1, 2, 7. Okay, so take 4 elements here and 3 elements here. So here we will take 5, 4, 6. Okay, the index will be 4, 5, 6. Okay, now we have divided our problem in sub problem, but the sub problem is itself bigger. Okay, now we want to divide it further. So let's divide it further. Okay, so again I will divide it equally. So we have 4 elements. So I can divide 2 and 2. So I will divide 3 and 1. And here I will divide 2 and 7. Okay, so our index will be 0, 1, 2, 3. Now here also divide it. So there are 3 elements on the right side. So what I can do, I can divide it in 2 and 1. So 5 and 4 will be here and 6 will be here. So our index will be 4, 5, 6. Okay. Now these are also bigger, right? These are also bigger. So let's divide it further. So if I divide it, it will be, so if I divide it, it will be 3, 1, 2, 7, and then 5, then 4. Okay. Do we need to divide it further? We already have one element here. So do we need to divide it further? No, right? We already have one element. How we can divide one element? So let's index it. So after dividing, it looks something like this. Okay, 3, 1, 2, 7, 5, 4, and 6. So we don't need to divide it further, right? We already reached to one element. We started with 7 elements. Now we reached to 1 elements. Okay. So after dividing, what I will do? Let's come here. So this is 3. This is 1. Okay. Now can I sort in 3 and 1? Which is smaller? Which is smaller? 1. Right. So can I do something like this? If I take an array, okay, if I take an array and I store the result of these two. So what I can store here? I can store 1 here, right? I can compare 1 and 3. 1 is small, so I can store 1 here. Next, I can store 3 here. Okay. So the sorted array will be 1 and 3, right? We solved our small problem. Okay. We solved our small problem. Okay. So after sorting, what I will do? I will move these elements to my original array. Okay. So I will sort it here. It will be 1 and 3. Okay. So 1, 3 we have solved. Okay. Now let's solve 2, 7 problem. So 2 is here, 7 is here. Okay. Compare. Let's take an auxiliary array. Okay. Of size 2. Now compare 2 and 7. Which is smaller? 2 and 7. Which is smaller? 2. So take 2 here and take 7 here. Okay. Now move these elements to my original array. So this will be 2 and this will be 7. So we have sorted this part also. We have sorted this part also. Okay. Now come to this part. So to solve this, what I can do? I have to compare 1, 3 and 2, 7. Okay. So let's compare it here. So we have 1, 3 and we have 2, 7, right? So how can I combine them? Okay, so let's take an auxiliary array of size 4, and what I will do, I will compare this and this. Which is smaller? 1 is smaller, so put 1 here. Okay, now I will compare 2 and 3. Which is smaller? 2. Okay, so put 2 here. Now compare 3 and 7. 3 and 7. Which is smaller? 3. So put 3 here. Now we only left with one element, so put it here. Okay, so this will be 1, 2, 3, 7. This is our sorted array. Okay, so this will return our 1, 2, 3, 7. Okay, now come to right side. This part we have solved, right? This whole part we have solved, right? So after sorting, my array become 1, 2, 3, 7. Okay, so my left part become 1, 2, 3, 7. Now we will solve right part. Let's come to here. Okay, so we have 5 and 4. What we will do? We will take an auxiliary array of size 2. Now we will compare 5 and 4. Which is smaller? 5 and 4, which is smaller? 4. So we'll put 4 here. Okay, and remaining 5 we will put 5 here. Now we will replace these elements. Okay, so this is our original array. We will replace this in original array. So this will become 4, this will become 5, right? So pass our sorted array. So this will be 4 and this will be 5. Okay, now left side have solved. Come to right side. Okay, so right side we only have one element, right? So if we have only one element, that is sorted. Okay, so we only have one element, so there is no other element, then it is already sorted, so pass it. Okay, so this will be 6 only. Okay, so now here what I will do, I will compare this array 4, 5 and 6. So I will take an auxiliary array of size 3, and what I will do, I will compare 4 or 6, which is smaller, 4. Okay, so write 4 here. Okay, so in 5 and 6, which is smaller? So in 5 and 6, which is smaller? 5. So write 5 here. And left, we will left with 6. So write 6 here. Okay, so this is also sorted. So replace it in the original array. So this will be 4, 5, 6. Okay, so on the left we got 1, 2, 3, 7. On the right we got 4, 5, 6. Right. So what I will do now, I will merge these two subarrays. So on the left we have 1, 2, 3, 7. Right. And on the right we have 4, 5, 6. Okay. So now we want to merge them. So what I will do, I will take an auxiliary array of size 7. Okay, 0, 1, 2, 3, 4, 5, 6. So what I will do, I will compare this element and this element, which is smaller, 1. So put 1 here. Now I will compare 2 and 4, which is smaller, 2 or 4, which is smaller, 2. So I will put 2 here. Right. Now I will move this. I will compare 3 and 4, which is smaller, 3. So I will put 3 here. Now move it further. 7 and 4, which is smaller, 4. Okay, so put 4 here. And now move this to here. Now compare 7 and 5, which is smaller, 5. Right, so put 5 here. Now move this index. See carefully, I'm moving the indexes. Right, so see carefully where I am moving the indexes from the first array and where I am moving the indexes from the second array. Okay, so if my element from first sub array is smaller, then I am putting this in my auxiliary array and moving the index of that sub array. If my element from second sub array is smaller, then I am putting it here and I am moving the index. Okay, so now comparing 6 and 7, which is smaller, 6. So put 6 here. Okay, so this is exceeded. Right, so this subarray is exhausted. Right, so we left with only one element in our first subarray, so we will move it here. So this will be our sorted array. This will be our sorted array. Right, now what if in the first subarray, if in the left side subarray we had 8, 9, 10 also? So what we could do, if one array is completely exhausted, what we can do, we can simply copy all the elements from our remaining subarray to my original array. Right, why? Because see, this array is sorted. Right, this array is sorted. Now we exhausted all the elements in our one subarray. So in this subarray, all the elements will be in sorted order, so we can put it directly here. Right, we can put it directly in our original array. So that case we will also handle. Okay, so that's how we can sort all the elements using our merge sort. So let's revise it quickly. So what we are doing, we are first breaking our problems into sub problems, that is nothing but divide. Okay, so once we reach the case where our element size is 1, okay, where our element size is 1, then we will start solving the problem. Okay, so what we will do, we will start merging it. So how we can merge it? We can first compare which element is smaller. So out of 1 and 3, 1 is smaller, so 1 will put here, 3 will put here. And after sorting, what we will do, we will move all the elements from my auxiliary array to my main array. Right, So 1 3, this part will be sorted after this call. Okay, so I will move all the elements, that is 1 and 3, to my original elements. So my 0 index will hold 1 and my first index will hold 3. Okay, so here also I will compare 2 and 7. Now in an auxiliary array I will compare, and once sorted I will move it in my original array. So this will be 2, this will be 7. Okay, so after solving this and this, I will sort this part. Similarly in the right subtree. So we are doing two steps. First we are dividing, and another we are solving them. So we are solving them by merging them. Okay, so we are merging them in sorted order. So let's write our pseudocode. So our pseudocode is something like this. First we will call our merge sort from our main. Okay, so merge sort will have what? It will have our array, right? It will have our starting index, it will have our ending index. Okay, now inside this what we will do, we will divide our elements. So I will call a recursive function for n by 2 and n by 2 elements. So first what I will do, I will take a mid. Okay, so to divide the array in two parts, I will take a mid. So first array will be from first element to mid, and next sub array will be from mid plus 1 to my last element. Okay, so it will take start plus end by 2, right? Now we will call our recursive function for n by 2 elements. So we'll call merge sort for, I will pass array, I will pass my start index. Okay, so first sub array will be till my mid element. Now I will call another merge sort for next n by 2 elements. So merge sort, I will pass array, and this will be start from mid plus 1, right? Because till mid I have taken in this first call. Okay, so I will pass mid plus 1 till my last index. So my last index is end. Now we have divided our array in two parts. Okay, this will keep on dividing till our problem become very small. Okay, so how much small? So if my start index becomes greater than or equals to end, that means what? We have only one element. Okay, we have only one element, or we have exceeded the array. So what I will do, I will return, right? So if there is only one element, what I will do, I will simply return. Now we have written our single element, okay, so we need to compare these two, and sort it. Okay, so let's say we have 3, we have 1, so we will sort it and put it in our auxiliary array. So who will be responsible for it? We will call a merge algorithm. Okay, so merge algorithm is responsible for all the sorting tasks, right? So we will call a merge algorithm. So merge algorithm will do our array. Okay, so it will take our start, okay, it will take our mid, and it will take our end. Okay, so this merge algorithm will take care of all the sorting tasks, right? Now let's talk about time complexity. So this will take order of 1 time, right? This is a simple if else condition. So this will take order of 1 time. Now this statement will take order of 1 time. Okay, now this, we are dividing our algorithm, so this will take t n by 2 time, right? Let's say the whole algorithms take t of n time, so this will take t of n by 2 times, and similarly this will take t of n by 2 times. Okay, so till now the time complexity will be something like this. Now we will discuss the time complexity of merge algorithm while discussing the merge algorithm. Okay, so our basics merge sort algorithm looks like this. Okay, so first we will divide, and after dividing we will merge them, and merge algorithm will merge them in sorted order. Okay, so one more thing I want to discuss. Let's see this int mid equals to start plus end by 2. Okay, so this will be work fine for many cases, but there will be cases where it failed. Okay, so what can be those cases? Let's discuss. So do you know the range of int? Let's say int stores elements from 1 to 10. Now let's say we have array of size 10. Okay, so from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's say we have array of size 10. So now while performing merge sort, what will happen? Let's say it will keep on dividing. It will keep on dividing. Okay, here also. So let's focus on right side. So let's say keep on dividing. Okay, so there will be one point of time where my element will be at 9th index. Okay, so there will be one point of time where my element will be at 9th index. Okay, so here my start will be what? My start will be 9th index. Okay, my end will be 9th index, right? So while keep on dividing, I divide until I reach one element. Okay, so here my start will be 9, my end will be 9. Now if I store mid in int, okay, what will happen? If I store it in mid, what will happen? Start is 9, end is 9. It will be what? And start plus end by 2. That is our equation, right? So it will be what? 18. 9 plus 9 will be 18. Okay, let's see this. So when it reaches 18, what will happen? Our integer stores till 10 only, right? And I want to store it 18. What will happen? It will overflow, right? It will overflow. So that can be happen in this case. Okay, so you will say that 18 by 2 is 9, so it is in range. But our system perform operation one at a time. Okay, so when it will go this operation 9 plus 9, 18, it will here itself give overflow, right? It will not perform that divide by 2 operation. It will here only will give overflow. So what's the better way to calculate mid? What's the better way to calculate mid? Till now what we are doing? We are calculating mid as mid equals to start plus end by 2, right? Instead of this, what we can do? We can do something like mid equals to start plus end minus start by 2, right? So what will happen? Okay, let's see this previous example only. So my start is 9, my end is 9. Okay, and int can store only till 10, right? So my start is 9 plus end is 9 minus start is 9 by 2. So it will be nothing but 9 plus 0 by 2, which will be 9 only. So this will not give us overflow error, right? So that is a better way to write mid. Okay, that is a better way to write mid. It will never go overflow, right? It will never overflow. So let's use it here. It will be start plus end minus start by 2. Okay, so this will be our mid. Okay, so let's discuss merge algorithm. So what merge algorithm does? Merge algorithms take what? It takes array, it takes first element, let's say start. Okay, it takes mid, and it takes last element, so let's say end. Okay, so now what is my purpose? My purpose is to sort the elements from my start to end. Okay, so what I will do, I will take one more auxiliary array. Okay, so let's take array, let's name it as AUX. Okay, now what size it will be? What size it will be? It will be the same size of our end minus start plus 1. Okay, so let's say my array is starting from 0 and my end is 9. Okay, so 0 to 9, how many elements are there? 10 elements. Okay, so what I will write? End minus start plus 1. Those many elements will be there. Okay, so it will be same as the size of the array which we are sorting. Okay, let's say I want to sort the array of 2 size, so it will be 2 only. Let's say I want to sort the array of 5 size, so it will be 5 only. Okay, so here initially what we are doing, we are passing 0 and 9, so it will be end minus start plus 1. Okay, you can take it in variable, then store the variable itself. Okay, so I will take the auxiliary array of size as same as this array which we are sorting. So we have taken the auxiliary array of size and minus start plus 1. Now to traverse through the auxiliary array, we'll start from 0th index. Okay, so let's take the index, let's say aux index. Initially it will be what? 0, right? Because we want to sort the array and then put it in the auxiliary array. So initially it will be put in the 0th index, right? Now let's take a variable for, let's say, low, and my low will contain the starting index of the array. Okay, so it will be the start. Now let's take one more variable, high, which will store the first index of our second sub array. Okay, so the low will store the first index of our left sub array, and the high will store the first index of our right sub array. Okay, so int high equals to mid plus 1, right? So you can understand it like we have this sub array, okay, so this is from 0 to 4, this is from 5 to 9, right? So this is our low, this is our high, right? And we want to store the result in our auxiliary array. So this is our auxiliary array, and this is our first index of our auxiliary array, right? So what we want to do, we want to compare this and move it to this element, right? So this will be stored in our auxiliary index. So till now we have taken 4 things. We have taken our auxiliary array, we have taken our auxiliary index, okay, we have taken low, we have taken high. So we have taken low and high to mark the current indexes of our both sub array. Now what I will do, I will run a loop from low while my low is less than equals to mid, while my high is less than equals to end. Okay, so let's take a loop while my low is less than equals to mid, and while my high is less than equals to end, right? Because we want to traverse these sub arrays. Okay, so we will traverse until their size. So what I will do, I will compare the element at my low index and at my high index. Okay, so if this element is less than this element, then what will happen? We will store this element in our auxiliary array. Okay, so I will store my low element at aux index. Okay, so aux index equals to what? Array of low, right? And what I will do, I will increment this index. So I will increment my low, so low will be low plus plus. So increment aux index also, so aux index plus plus, right? If that is not the case, then what will happen? I will copy my array from second sub array. Okay, so I will copy aux index equals to array of high, right? And I will increment high, so high plus plus. Now my high will be here. Okay, so I will again increment my aux index. So this will be my else part, right? So here also I will increment aux index, here also I will increment aux index. Okay, so in both the condition I will increment aux index. So what I can write it outside the if else condition, right? because if any of the condition fulfill, my aux index will be increment. So I can write outside my if else condition. So aux index will plus plus. Okay, did you understand it? Because if my if condition satisfied, then I will increment my aux index. Else also I will increment my aux index, because it will store one value either from this array or from this array. So my aux index will keep on incrementing every time. So I will increment it. Now you feel my task is done, right? But there are few more conditions. Okay, so let's say my subarray contains like 10, 20, 30. Okay, and it contains 40, 50, 60, right? 0, 1, 2, 3, 4, 5. Now if I perform merge algorithm in these, what will happen? Let's say this is my auxiliary array. Okay, so first it will store 10, right? Then it will compare and store 20. Then it will compare and it will store 30. Then this subarray is exhausted, right? It is exhausted. So what will happen in this while loop? If both the array is not exhausted, then only it will run. Okay, so if my one of the array is exhausted, what will happen? We have to handle the case for next subarray, right? So how we can handle this? What I need to do, I need to put all the elements of my next subarray in my auxiliary array, right? So if one of the subarray is exhausted, I will put all the array elements of next subarray in my auxiliary array. So write conditions for this while. Okay, so while let's say my low is less than equals to mid, what I will do, in my aux array, in my aux index, I will put array of low, right? And increment low and increment aux index, right? Same condition can happen with second subarray. This I have written for first subarray, right? If my first subarray contains element which are not exhausted, so this is for first subarray. Now my second subarray contains element like in this example. So what I will do, I will write a condition for this also. So while my high is less than equals to end, then what I will do, I will store aux index. My auxiliary array will store array of elements at high index, and I will increment my high and I will increment my aux index. Okay, so this is my program for merge algorithm. Okay, so we have handled the conditions, right? Now my auxiliary array, this is my auxiliary array. Okay, so it stores the element in sorted order, right? It stores the element in sorted order. Let's say 1, 2, 3, 4, 5, 6. Okay, but I want to sort my original array. So what I will do, I will move these elements in my original array. Okay, so I will take a for loop for int I equals to, now here what will be my starting index, which is passed to the merge algorithm. So in merge algorithm, here start is passed. Okay, so I will start a loop from my start index and I will run this till my end. Okay, so it is nothing but end and I plus plus, and what I will do, okay, so I will move the elements at array of I equals to, I will move from my aux index. Okay, so mark aux index as 0 because my aux index contains sorted elements from 0 index, so mark it as 0. Okay, so what I will do, I will copy this from aux index. So aux index, okay, and aux index will keep on incrementing. Now I will copy all the elements from aux array to my original array. So this is our program for merge algorithm. I have written the code for merge algorithm. This is the complete code almost. So if there is minor mistake, we can rectify it while coding it. Okay, now what will be the time complexity of merge algorithm? So if we see in merge algorithm, what we are doing, we are running this while loop, right? We are running this while loop, right? We are running this while loop, right? And we are running a for loop. So this for loop will take order of n times, where n is the number of elements which we are sorting. Okay, so this for loop will take order of n time, and the above while loop, the three while loops completely will take how much time? So let's say these are our two sub arrays. Okay, now my auxiliary array of size what? Let's say n. My auxiliary array of size n. Okay, so how many times this while loop and this while loop and the third while loop will run? So it will run for total of n times, right? Because it will copy all the elements from first sub array, it will copy all the elements from second sub array. So total size will be order of n. Okay, so my merge algorithm will run for order of n times, right? So order of n for this for loop and order of n for my while loop. Okay, so it will run for order of 2n times. Now this can be written as order of n times. Okay, so my merge algorithm will take order of n times. Okay, so now come back to my merge sort. We have seen that merge will take order of n times, right? So if I write my recurrence relation, what it will be? So it will be T of n will be equals to order of 1 if my n is 1, right? If there is only one element, then it will take order of 1 to sort it, right? If n is greater than 1, then it will take T of n by 2 for this merge sort plus T of n by 2 for this merge sort plus n for this merge algorithm. Okay, so it will take 2 of T n by 2 plus n. Okay, so after solving using Master's algorithm, after solving using Master's theorem, okay, the time complexity of this algorithm will be order of n log n, right? So this will be my time complexity. Now those who don't know about Master's theorem, it's a very easy theorem to find the time complexity. Okay, if we have given the recurrence relation, it is very easy using master theorems to find the time complexity. So the time complexity of merge sort will be n log n, right? In best case, in worst case, in average case. In all the cases, the time complexity of merge sort is n log n. That's why it is most preferred, right? Because other algorithms, let's say in bubble sort, in quick sort, the worst case time complexity is order of n square. But in my merge sort, the time complexity is n log n for all the cases, right? Now, there is one more question which comes in OA or in MCQ type problem related to merge sort. So the question says that how many comparisons and swaps merge algorithm takes. Okay, so sometimes this question comes in the MCQs that how many comparisons and swaps merge algorithms takes. So let's say we have two sub arrays of size n by 2 and n by 2. Okay, so how many swaps, or we can say moves, how many moves merge algorithm will take? So what we will do, we will, after sorting, we will move it in our auxiliary array, right? So this is our auxiliary array. So how many moves it will take? So we have n by 2 elements here, we have n by 2 elements here. Okay, so total elements will be n. So how many moves it will take? Total moves it will take will be n, right? Now how many comparisons it will take? So the comparison it will takes, so again we have n by 2 elements, we have n by 2 elements. Okay, so in worst case what will happen? So in worst case what will happen? we can have n minus 1 comparisons. We can have n minus 1 comparison. Okay, so in which case, let's say example. Okay, so let's take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in this case, what will happen? First element comes from this array, second element comes from this array, third element comes from this array, fourth element comes from this array, fifth element comes from this array, sixth comes from this array, seventh comes from this array, eighth comes from this array, ninth comes from this array. Okay, so there will be n minus 1 comparisons. There will be n minus 1 comparisons in worst case, right? In any problem, if it asks for comparisons or moves, we need to say the worst case complexity. Okay, so in worst case, there will be n minus 1 comparisons. In worst case, there will be n moves. So n moves will be in every case, right? Because we are moving in auxiliary array in almost every case. So we will have n moves and n minus 1 comparisons, right? So this is a very frequent asked questions in the MCQs, OAs. So this question can be asked for any sorting algorithm, right? So in every sorting algorithm, we will see how many comparisons and how many swaps it will take. Okay, so in this algorithm, we have seen merge algorithms takes these many swaps and these many moves. Okay, so this was all about merge algorithm, and I guess I have covered a lot about merge sort and merge algorithm. Now let's code it in our Visual Studio Code. Okay, so we are solving merge sort. Let's take an array of, let's say, size 5, and let's take 2 comma 1 comma 3 3 comma. Okay, so let's take this array and call our merge sort. So merge sort, and I will pass my array. I will pass my starting index as 0, ending index as 4. Okay, so I will create our function merge sort. I will take ARR, I will take start, I will take end. Okay, so let's take it as void. So let's say if my start is greater than equals to end, that means if we have one element or if we have exceeded the index, so I will return. Now if that is not the case, I will call the merge sort for n by 2 elements. So it will be array, and my start index will be same. My ending index for first subarray will be mid. Okay, so let's create mid here. Int mid equals to start plus end minus start by 2. Okay, now I will call my merge sort for next subarray. So its index will be mid plus 1 and end will be same. Okay, so after dividing, what I will do, I will call my merge algorithm. For my array start, I will pass mid, I will pass end. Okay, so now merge algorithm will take care. Let's create our merge algorithm. So it will be of void merge. I will take array, and I will take int start, I will take int mid, I will take int end. Now in merge algorithm, what I will do, I will take an auxiliary array. So let's take an auxiliary array as AUX, and its size will be end minus start plus 1, right? So this will be our auxiliary array, and let's take auxiliary index as 0, because initially I will start from 0 in our auxiliary array. Okay, so now let's take our low as start, our high as mid plus 1, right? Why? See, these are first index of first subarray. Okay, and this is first index of second subarray. Okay, so what I will do, I will run a loop while my low is less than equals to mid and my high is less than equals to what, end. Okay, So in while loop, what I will do, I will check if my element at array of low is less than equals to my element at array of high. So what I will do, I will update my aux index. Aux at, okay, so this will be aux index. Aux index equals to array of low, right? Now what I will do, I will increment low and I will increment aux index at the last. Okay, so in else what I will do, in my aux index will be equals to array of high. So my high will be incremented, and at any case I will increment my aux index plus plus. Okay, so this will run till my low and high is within range. Okay, if one of them is exhausted, okay, so let's say my second subarray exhausted, then what I will do, I will write a loop for while my low is smaller than equals to what, mid. I will copy all the elements of my first subarray in aux index. Okay, so at aux index what I will do, I will copy array of low. Here I will increment low and aux index as well. Now if I exhaust first subarray is exhausted, so what I will do, I will copy all the elements from second subarray in my aux. So while high is less than equals to end, what I will do, I will copy aux index equals to array of high. Okay, so I will update my high, I will update my aux index. Okay, so till now my aux index contains all the elements in sorted order, right? So I have copied all the elements in sorted order in aux. Okay, so I will copy all the elements from my auxiliary array to original array. Okay, so let's run loop. Int I equals to what, start, I is less than equals to what, and I plus plus. What I will do, I will copy all the elements of aux. Okay, so now here let's take aux equals to 0 because I want to copy from 0th index. So here aux equals to, you can take another variable as well, so there is no issue. Okay, now what I will do, I will update my aux index. So this is my merge algorithm. Okay, so this 3 while loops will take order of n times, right? And this for loop will take order of n times, where n is our n minus start. Okay, so my n is equals to end minus start plus 1. Okay, now what I will do, I will run a for loop to print all the elements. Okay, so 0, I is smaller than I plus plus. Now cout arr I. Okay, and at the end I will do handle. So let's run it. Unused aux index. Oh, sorry, this will be aux index plus plus. Okay, aux index plus plus. So yeah, I guess this will work fine. Let's run it. Okay, so 1 2 3 4 7. 1 2 3 4 7. Okay, so this is our sorted array. So if you write something like this, it will be much better. So let's run it again. Yeah, 1 2 3 4 7. So this is our sorted array. Okay, so let's change it to 2 2. Okay, now let's run this. 1 2 2 7. Okay, one more thing I want to say is merge sort is outplace, right? Because we have used external aux array to sort the elements in merge algorithm. Okay, now merge sort is stable. Okay, so merge sort is a stable algorithm. Why it is stable? Because it doesn't change the order of repeated elements. So in this case, 2 is repeated, right? So 2, 2, 2 here. Okay, so it will keep the order of repeated elements in same way. So first this 2 will come, then this 2 will come, then this 2 will come. Okay, so it is stable and it is outplace. So merge sort keep the order of repeated elements in the same way as in the original array. Okay, after sorting, it doesn't change the order of repeated elements. Okay, so merge sort is outplace and it is stable. This question is also asked in my interviews. Okay, so this is all about our merge sort algorithm. I hope you find it useful. Okay. So if you want to refer the notes of this lecture, so you can scan this QR and you will get the notes of all the sorting algorithms. In this notes, we have covered insertion sort, selection sort, bubble sort, heap sort, merge sort, quick sort in detail. Okay, so if you have any doubt, you can read these notes. And this was all about this lecture, and we will meet in the next lecture. Till then, bye bye, take care.